Okay, so the last set of notes were triangle congruences, where we had to list all the pieces of the triangles. So if all 6 pieces of the triangles were congruent to all 6 pieces of another triangle, you could say the triangles were congruent. So if all 3 sides and all 3 angles making 6 pieces. Today, I'm going to give you some shortcuts. So instead of using all 6 pieces, if you know these 3 things in this order, you'll be able to use shortcuts instead of naming all 3 things, all 6 things. So remember last notes we had to say all 3 angles, all 3 sides were congruent, then our triangles are congruent. All 3 angles, all 3 sides were congruent, we could say triangles were congruent. Today we're going to have some shortcuts. We have 5 triangle congruence shortcuts. This is 4.5 on page 140 in your note guide. Our 5 triangle shortcuts are first, SSS. So the 2 we're going to learn about today are SSS and SAS. I am going to fill out all of these as a reference sheet that you want to kind of come back and look for. In your note guide, if you have maybe a blank sheet of paper, you could put it underneath that first sheet. And if you take a highlighter and highlight the corner of it, it's kind of like a hint or a tip that when you flip through your notebook now, it's going to have this highlighted edge. This is a really important page. You want to be able to come back and find it. Put a sticky note on it, highlight the edge of it, and if you put the paper underneath it, it doesn't highlight the other edges, and you'll be able to find it more easily. So the first one is side, 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 which means if you have 3 pairs of congruent sides, if I know this side here is congruent to this side here is congruent to that side, and this one here is congruent to this one. This one is going to be side, side, side. If I have this, I know the triangles are congruent, all their sides are congruent. I also know the corresponding angles are congruent. Now I could have a side, angle side. This one is 2 sides and the included angle, meaning the angle between the 2 sides. So let's say that this side was congruent to this side, and this side is congruent to this side. Which angle is between the 2 sides here? Is it this angle, or this angle? Now I always think where the sides meet, the 2 sides meet right here, that's the angle we're looking for. That's the included angle. This one right here is the included angle. So if I know this side is congruent to that side to that side, and if I know this angle here is congruent to this angle here, I can then say those triangles are congruent by side, angle, side congruence. Now my other ones, which we're not going to do these today, but I'm going to fill them out. Angle, side, angle means I have 2 angles and an included side. This one in green. So let's say I have this angle here is congruent to this angle, and this angle here is congruent to this angle. Now which side is between or included between those 2 angles? So it's the one that connects the 2 angles, this side and this side. So I know that this one is congruent to that one. So I have an angle, side, angle. Now the next one is going to be angle, angle, side. This time, 2 angles and a side opposite them. 2 angles and a non-included side. So let's say I have the same 2 angles. Let's say we have this angle here and this angle here, this angle here and this angle here. Now I don't want the included side. I need a non-included side. So it could either be this side here and here, or it could be this side here and here. It doesn't really matter. It could be either one. Let's go ahead and make this the non-included side. And it could be this one here. Now again, it could be either of these. It can't be both, but it could have been either non-included. Okay, now our last one is HL, hypotenuse leg. So if you have a hypotenuse, remember, this is a special case. If you see the word hypotenuse, you know that you have a right triangle. And you are looking for the hypotenuse, which would be this right here, and any one of the legs. It doesn't really matter which leg. It'll either be the height or the base in either of the legs. So we'll say it's this leg here. So now this is technically called side-side angle. I usually do that. I'll put letters in my, I would put side, side, side. I would put side, angle, angle, side, angle. And when I put the letters, see how it forces the name that I'm looking for? Angle, angle, side. This one is side-side angle, which technically, if we wrote that in the other direction, would be a bad word, right? Okay, so the bad word does not work ever unless it's a right triangle. The only time it works is when it's an HL. So it has to be a right triangle for side-side angle to work, and then we don't call it the bad word, okay? We call it HL. So keep that in mind. Reasons sides are congruent. Here are reasons that we've used before. Given, definition of midpoint. Reflexive property is one that's going to start coming up a little bit more frequently. Given, vertical angles. These will start coming up more frequently as well. Remember, those were the ones that we did when we have parallel lines cut by a transversal. Definition of angle bisector. And we will start using CP/CTC after we say triangles are congruent at some point. So, if triangle ABC is congruent to triangle DEF, then I know that AB is congruent to something, BAC is congruent to something, and BC is congruent to something. I also know that angle A is congruent to an angle, angle B is congruent to an angle, angle C is congruent to an angle. So this is kind of what we did before, all three sides, all three angles. But if I know any of these up here, if I know a triangle is congruent because of those three, I know everything about that triangle is congruent. I can say line segment DE, line segment DF, line segment EF. I could say angle D, angle E, angle F. These are line segments. I do not put lines above them. So I know all of those are congruent. If these triangles are congruent, everything about them is congruent. I know this side is congruent to this one to this one, this one to this one. I tend to also mark everything I know when I have a triangle congruent, because then visually I can see it right away. Okay, I'm going to pause for a minute and we're going to go use this on the next page. Okay, so we just basically did some of these on the other side. We're going to be doing 2 triangle congruences today, side, 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 and side angle side. The first page was basically a preview for what we're going to be doing in the next week. So right here, if I know this side to this side, this side to this side, this side to this side, I'm not going to make you rewrite it again. You can if you'd like. We just did it basically on the other page. Then you know the triangles are congruent. You can write a triangle congruence statement. So I'm going to say, well, triangle, I'm going to name this one alphabetically, ABC, would then be congruent to triangle. Name it in the order of congruence. This one may not be alphabetical. Go 1, 2, 3. So D, E, F. Now right here I have a proof. You have all of the statements. Can you pause, try to fill in any of the reasons you can on your own? Well, up here when I look at this, I have PQ equals ST here and here, QR equals TR here and here, R is the midpoint of this here and here. That's all right up top. I can go ahead and say that this is given for the first 3 statements. Now, as soon as I have given information, I'm going to go to my diagram and mark everything I know. So if I know PQ is equal to ST, QR is equal to TR, I put 2 tick marks for that one, and I know that R is the midpoint of PS. Well, if R is the midpoint of PS, doesn't that mean that this side over here and this side over here have to be the same? Which is what I'm going to put right here. PR is equal to SR. Because that's my definition of a midpoint. Now, if I know this, can I say those triangles are congruent? Well, yeah, I have a shortcut that says if I know side, 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 I know the triangles have to be congruent. And there you go, that's your proof. You just have to justify each step. So again, go ahead, pause, see if you can fill in anything on number 2, and then continue on. I usually start with reading up here the given. JL and NM is here. K is the midpoint of these 2 right here. So again, these are given. JL is equal to NM right here. Then I know K is the midpoint of JN. K is right in the middle. And if it's exactly in the middle, that means that this over here and this over here have to be the same. It's also the midpoint of LM. It doesn't always have to be, but in this case it is. Which means this over here will be congruent to this over here. So did I just say that JK and NK were equal? And LK and MK were equal? Why did I know that? So why you knew that is your reason, because they told me right here in both of these that this is definition of a midpoint. They told me there were midpoints, and that's what a midpoint does. Now looking at this, I can see right away that I have side, 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 congruence. Okay, we are not going to do all of the problems in this entire section, but I do want you to flip and go ahead and do number 3 on the next page, and then I'll unpause. I'm going to pause. Go ahead and fill up at 3 if you can. Okay, so there isn't anything to start with on the proof, so you have to kind of start with what they gave you up here. Now, they gave me 2 things of given. I can write them down here. So I basically know those 2 things, that AC is congruent to AD, and I know CB is congruent to DB. These are both given. What else could I fill in if I needed to? Well, whatever I need to prove. I want to prove this at the end, so this goes ahead and goes down here at the bottom. I want to say that the triangle ABC is congruent to triangle ABD. Now, I don't know the reason yet. Whenever I have triangles congruent, it's going to be one of my 5, and I only know 2 right now. Side, 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 and side angle side. So it's going to be one of my triangle congruences. I just don't know which one yet. So I'm going to go mark my diagram. AC is congruent to AD. CB is congruent to DB. Now, do I know any other thing here has to be the same? Well, hopefully we see on these two triangles that this side right here is part of both of those triangles. I tend to, like, I like my note cards everywhere. Here's one. This triangle up here, AB is part of it, and this triangle down here, AB is part of it. So, I know that AB is congruent to itself. Hopefully you remember what property that is. When you look in a mirror, you see yourself. It's a reflection or reflective. Reflexive property. So now I have, again, side, side, side. There we go. Okay, I'm going to pause and we're going to do that in just a moment. So again, I'm telling you that these two triangles are congruent. If there is a side, two sides, and an included angle. I'm not going to make you write these down right here. You just want to go ahead and say the triangles are congruent. Triangle ABC is congruent to triangle DEF. So it probably doesn't hurt to write it down. You would say AB is congruent to DE. The angle would be angle B is congruent to angle E. Side would be line segment BC is congruent to line segment EF. Okay, I didn't do the first proof here. I did go back and I did the next two, 5 and 6. So if you want to go to the next page, and we're going to fill out 5 and 6. Half of them are already there, so you just have to fill in the reasons. Pause it, see if you can fill in any of those reasons on your own. Again, these are both given. Notated on the drawing, AB congruent to CB, BD bisects angle ABC, which means this angle here and this angle here have to be the same. So I'm going to say that those angles are the same. ABD is congruent to CBD because whatever's right above it is pretty much your reason for the next step every time, because that's my definition of a bisector. Well now, why can I say something equals itself? Whenever something equals itself, it's my reflexive property. Now, do I have enough information? I like to put the letters in here just to kind of verify that I have a side, an included angle, and a side. Again, a lot of this is proofs are not anybody's favorite usually. A lot of it is really looking at what do you know, can you fill in the blanks. I'm not going to ask you to do one completely on your own. I'm going to give you some and see if you can fill in some of the blanks. Down here, we're going to do 6. B is the midpoint of these. Right here, that's the only given. So V, WV, and ZV. These are equal. Why? Why do I know they're equal? It wasn't given, but it did tell me that V was the midpoint of WZ. So that's my definition of midpoint. Now I also know that WVX, this angle over here, is equal to this angle ZVY over here. Can you tell me why we think those angles would be congruent? Like, hopefully we remember back from like the first week. These are vertical angles. vertical angles are congruent. And then here it tells me that XV is equal to YV because it's the midpoint of XY. So again, here's another definition of midpoint. So it's using what we know to determine or prove what we want to prove. So now, do I have enough information? I have a side, an included angle, and a side. And that's what we're looking for. Okay, I'm going to pause. I think we're going to do like 1 or 2 more problems. Okay, so for these 8 problems on page 144, I'm going to ask if you can write the congruence statement. Okay, state whether the triangles could be proven congruent by either SSS or SAS. These are the only 2 we know right now. Okay, so SSS or SAS. These are the only 2 we know. Or you can say that they are not congruent. So you need to decide that and write the congruence statement. So here I have a side angle side. I can say then that these triangles, I'm going to start alphabetically. Now the first letter alphabetically is going to be CKP. I'm going to call this CKP. Is congruent to starting at C. I would also want to start over here at Q, and go to YT, QYT. Now then I'm going to have to say by one of these reasons. So this one is side angle side. Okay, I want you to go ahead and look at all these, pause your screen, fill in all your answers that you can. I'm going to pause and I'm going to go ahead and fill in them all and just have you check them at the end. Okay, so here are the triangle congruences, and why are they congruent? So we're going to have side, side. Well, I have this third side that is shared by reflexive property. So I'm going to say by side, 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 congruence. Now I like to write the SSS here. Now over here, sometimes it may be easier if you redraw these separately. And I know that this is congruent to this. I know this angle is congruent to this angle. And this side is shared at the bottom. It's hard to see, but this side right here is the same as this side right here. So this is going to be by side angle side. Now over here we have a side, side angle. So if we remember, side, side angle is a bad word going in the other direction. Is this a right triangle? So now this technically doesn't work. Now CEF would be congruent to triangle DEF. And we again share this reflexive side. So this one will be by side, side, side. This one over here, I have side, side. I know the vertical angles here work, but I also have, but side, side angle isn't going to work. So, can I prove one of the other angles? Notice that I have the 2 parallel lines cut by the transversal. And when I cut by a transversal, my alternate interior angles are going to be equal here and here. So I can say that I have side angle side congruence. Over here I have side, side angle, the bad word. Again, that's not going to work. so that one doesn't count. The last one, ABC congruent to EDC. I have two sides. I have this angle here. What are these angles called again? Those are vertical angles. So I have side included angle side. Okay, so I just wanted to go over that review with you guys quickly. That is it for that set of notes. These are a little bit long. I apologize because there's so many pages and you have to do that big review reference page on the beginning. The other ones this week shouldn't be as long. So anyway, have a fabulous day. Good luck, you guys. And I will see you next class.